Hello everyone, and thanks for tuning in. My name's Nick. I'll be running the webinar Becoming Regular with Regex today. Just to let you know, I'm going to wait another couple of minutes, give a few more people a chance to tune in, and then we'll get going. So I'll probably start in about 2 minutes' time. Hello everyone, thank you for tuning in to today's webinar. Today I'll be covering Becoming Regular with Regex. So let's get going. First of all, a little bit about myself. My name's Nick Jastrzebski. I work at the Information Lab. I've been using Alteryx for just over a year, before which I had never touched Regex before. So you can learn how to do this stuff pretty quickly if you have the time to dedicate to it. So what I'll be covering today, I'll be looking at what Regex is, so you actually understand what we're talking about. I'll take you through the language and the syntax around Regex, because there is quite a lot there. So we'll go through the fundamentals of that. Then we'll take a look at the Regex tool in Alteryx itself. So we'll have a look at how we can actually use Regex within the dedicated tool. And then I'll take you through a worked example of using Regex within a workflow to extract some data. So this is the use case that we'll talk through, which is essentially taking some data from some HTML code. So the Alteryx weekly challenges are a really good place to learn more about how to use Alteryx and get some more practice. On their website, in the forum, they have an index page with all the challenges. And what we're going to do is take the HTML from that web page and extract the data from that table to end up with something that looks a little bit like this, where we have our challenge number, the challenge name, the level of difficulty, and the subject of it, as well as a URL, which we'll be able to dig out of the HTML itself. So the HTML will be a bit messy, difficult to work with by itself. So we'll use some regular expressions to extract the information that we want. So what are regular expressions? What am I talking about? So Regex is just the short name for regular expressions. It's essentially a language, but it's designed specifically to match patterns within a string. So if you have a long block of text that's got information in it that you want to find out, it's not useless. It's possible with Regex to pull out parts of that information that you need. So it's very versatile, it's very powerful, and you can clean and extract data from very complex pieces of text. A good example of this would be if you are using, or if you have an address field in some data, but you want to take the postcodes from there, you could use a regular expression to extract that. The problem with that, normally without a regex, would be that your postcodes are all different. So you can't just look for a specific string within that text. You have to use an expression to match a type of text. But it's not perfect. As with all text analytics, there are limitations because you have quite intense memory intensive processing that goes on. Strings are very slow to work with a lot of the time. And because this is based on strings, it can be quite computationally heavy. It is a language, and as with any language, it takes practice and time to learn. So don't expect to understand everything overnight. And because it is a language and it is quite advanced, it can be difficult to work with, especially if you're working in a team where other people don't know the language. It's very important to be careful of documentation and handover with this kind of thing, because if somebody doesn't understand a regex expression that you've written, that you've put into a workflow, if they then come to it and have a look at it, they might have no idea what's going on. So it's very important to explain exactly what your regular expressions are doing, not necessarily explaining how it's doing it, so that it's clear for other people to understand. So let's talk about the language. This is only a small subset of everything that is available in the regex language, but these are the basic ones that will get you started. These are the workhorses of the language. It's broken down into 3 categories here. So we have qualifiers, quantifiers, and then others. So the qualifiers are the actual type of character that we're going to look for. And there are quite a few different ones that these are broken down into. So I'll go through each of these individually and explain what they do. So a dot or a full stop is a wildcard. This means that we can match any type of character whatsoever. There is no limit. This will just bring back anything. The \w, backslash lowercase w, is any alphanumeric character or an underscore. So that's any number, any letter, or an underscore. The \d is any digit, so that's any numbers at all. The \s is then a space. So these 3 also have an opposite variant. So if you use a capital instead of a lowercase, it will match the opposite. So a \W will be any character that isn't alphanumeric or an underscore. So that could be things like punctuation or spaces. The capital \D is anything not a digit. So that could be letters, it could be punctuation or spaces, and a \S is not a space. So literally any character as long as it isn't a space. Finally, we have these groups at the bottom, which are using square brackets. So these letters specify groups of characters that we can return. The language can understand the alphabet and it can understand number ranges. So here where we have A to Z, that means that it will match any letter in the alphabet from A to Z. It can also match varying cases as well. So here we've got capital A to Z and lowercase a to Z, so we can specify that. And then finally at the bottom, we have the numbers. So 0 to 9 will match any number from 0 to 9. Next, we have the quantifiers in the middle. So these are how we can specify how many characters we want to match. Qualifiers tell us what we're matching. Quantifiers tell us how many we match. So with the plus, we're looking for at least 1 of the preceding character, but there is no limit as to how many it can match. The star is 0 or more. So this essentially does the same as the plus, but makes that previous character optional. It might be there, but it might also not be there, but we could have any number of them. So it can be very, very versatile, that one. The question mark's a weird one. This has 2 different functions depending where you put it. So if you put a question mark directly after a qualifier, it means that that qualifier itself is optional. So there could be 0 or there could be 1. If you put a question mark after a quantifier, it means that it will match as few as possible of the previous qualifier. So for instance, if we had \d, then a plus, then a question mark, it will match as few numbers as possible. This probably doesn't make sense as I'm explaining it now, but it's quite important when we come to extracting regular parts of text, which we'll see in an example that I'll go through shortly, which will hopefully make that make a bit more sense. Finally, we have these curly brackets where we can specify a range of the number of characters we want to return. So if we have x, y, if we put 2, 3, that means that we match either 2 or 3 of the preceding character. So we can specify an exact range of how many we want. We could just put a single number in there and just say 4, and then it will always have to match 4 of that character. Or we could put 2, and then close the brackets, which would mean that it would just find at least 2, but there would be no limit as to how many there are. The last category that we've got is the others. So these perform some sort of function within the regex, but don't really fall into either of the other two categories. So first of all, we have the pipe. Pipe symbol, it just means that this works as an OR operator. So any qualifiers that we have either side of this, it could match either one or the other. The caret symbol is the start anchor. So this will always look at the very start of the string, so where the string actually starts, and then we can anchor our expression to that starting point. And then the opposite of that is the $sign. So the $sign will always look at the very end of the string. Regular curved brackets, round brackets, these create capture groups, which are very important for when we are extracting text. We need to actually specify which part of the expression we want to return. So we need to create a capture group to know which part to actually capture. And then finally, the \/ represents escaped characters. So you've probably noticed already in my qualifiers, I already have backslashes. So the \w, that is because the W has been escaped into a regex character. And the opposite works for any other characters that don't have a \. So for instance, if I put a \ before a plus, it means that my expression will, instead of looking for one or more, it will look for an actual plus the character itself. So we can convert back and forth between these special characters that perform a function and the literal character that we want to search for by using a \. So now that we know roughly what we're talking about with the language, let's talk about how to actually implement it in Alteryx. So we have a specific tool to use regex within Alteryx called the Regex tool. And this is a screenshot of the configuration pane of that tool. So we have 3 separate things that we need to work with in this tool. The first one is the green section. We need to actually tell it which field contains the text that we want to apply our expression to. Next, we need to actually provide the regex expression for it to work with. So this will actually have the syntax built with the language that we've just discussed, which will go into that box. And lastly, we need to specify the output method. So this is the actual function that the tool will perform. There are 4 separate functions within the regex tool. It can perform 4 different types of procedure. And I will take us through each of those individually as we go through our example this afternoon. So each of those has their own different way of configuring the tool, and I'll show you each of those as we go through. So let's have a look at the data and have a look at a hands-on example. So if we head over to the web page and just show you what this looks like in real life. So this is the weekly challenge index. Here we can see there are a number of different tables. The only one I'm interested in is this one down here at the bottom, where we have the actual list of challenges. Now, I've already extracted the HTML for just this table and put it into Alteryx for us to take a look at. So if I just head over to Alteryx, I'll show you what this looks like in here. So this is the actual string information as it comes through. And as you can see in this cell here, there is a lot of text. There's a lot of stuff that is just very messy. Doesn't really mean anything to me at the minute. So what I'm going to need to do is create an expression or a set of expressions to be able to extract the text that I actually want from this huge block of text. So at this point, it becomes a little bit important to understand the pattern within this table, within this text, so that we know what to extract. So it's a bit helpful to understand HTML coding itself if you're going to be doing this kind of thing a lot. But if you don't, it doesn't matter. You don't need to know what the characters mean, or you don't need to know what all these different tags mean. You just need to identify the patterns within them. So I have an example in here where I have pulled out a clean version of this here. So this is with it broken down onto each line to make it a little easy to see what we're actually looking for. So this is the same data that we've got in our Alteryx input, but I'm just showing it here so that we can break it down and see what we're trying to actually match. So the first thing we need to do is actually denote our rows, because at the minute everything is all in one cell, it's all squashed together into the same string. First thing we need to do is split things out. So we'll have each of our individual rows. Well, first of all, we've got the table, which is the whole thing. So that's that label there. But first, once we have our table, we need to identify the rows within that table. So each row is denoted here in the red. We can see that it starts with this TR tag. So that's what we're going to need to use to be able to reference when we're starting a new row. Next, we want to look at the columns that we need to extract. So it might be a bit difficult to see because they're a little bit misaligned, but the header is on the first line. We can see in that strong tag, we've got the little hash symbol, which is the name of our first column, which is the challenge number. Then around that strong, we have the TD, which is the same tag that we have going down the rest of the column. These aren't the same width all the way down, so we can't use a nice, easy, fixed width text to columns or something like that. We're going to need to use an expression to say, whenever I have something within this TD tag, extract it into a new column, which is the same if we look at our next column along. Again, you can see here, this is very variable length. So we're going to actually have to look for where these TD tags are. So we can see on row, or the very first row, we've got the name of the field, and then under that, we've got the name of the challenge as it goes down. But within this field, we actually have two pieces of information. We have our page URL, so this is the actual link to go to the challenge itself, and we have the challenge name. So we'll also need to be able to extract that from here as well, which means that we'll have two fields being generated. From this one column in the table, we'll have our challenge name, and we'll have our page URL. So the tags themselves, we don't need to know what they mean. We've just identified where the different bits of information are that we want to bring back. So let's head over to Alteryx and actually start extracting this. So the first stage is to split out our rows of the table, which we identified earlier as being part of this TR tag here. So each row starts with a TR. I have a nice handy cheat sheet here to do the hard work for me. But the first thing I need to do is bring in a Regex tool. So I'll just drop that onto the canvas and connect my input into there. So here is the interface that we are working with. So first things first is to select the column that we're going to apply our Regex to. We only have one, so I'll leave that as my weekly challenges column. Next, we need to specify our expression. So as I mentioned, I have my cheat sheet here. So I'll just copy this in and then talk you through what it does. So this expression here is saying find any TR tag, and then this $* is saying find a wildcard, one or more of it, but as few as you possibly can. So that means that it will stop as soon as it gets to the next closing tag. And then again, find anything after, absolutely anything after that tag until you get to the next closing TR tag. So we're matching here a single row because our row starts with a TR and it ends with a TR. So what we need to do next is change our output method. We need to actually tokenize here. So the tokenize works in a similar way to text to columns, but instead of tokenizing or splitting to columns based on a single delimiter, here we are splitting based on our expression. So what we can do is set to tokenize, and then we can split to rows down here. So that means that every time this expression is true, we will get a new row, which is exactly what we want, because we want to split this single block of text over here out into each row within our table. So if I run this workflow and then have a look at my output, I can then see down here, it's now starting to look a bit better. We can see straight away, we've got each of our rows split out. So we can see at the very top, we've got the name, and then the next row down, we have challenge number 1, then challenge number 2 and 3. So straight away, we've made a good start. The next stage is to split out into columns so that we actually have our actual table start to make shape rather than just everything in a single column. So for this, I will again want to tokenize. So I'll bring in another Regex tool and connect this up. So once again, start off by choosing the column that we want to parse. Again, we only have one column at the moment, so I'll leave that as weekly challenges. And then we want to specify another regular expression. So if I hop back over to my cheat sheet, I can copy this one across and paste it into my box. So this is very similar to my previous expression, but now instead of looking for TR, we're looking for TD, because the TD is each of our different columns within the data. So we're saying find the first TD tag, find anything after that until you hit the next TD tag. So I'll need to change my method over to tokenize again, because I'm splitting out this one column into other columns. And this time, instead of choosing to split to rows, I want to stay on the split to columns, but I want to split into 4 columns instead of 3. So that means that I will get one new column for each of the columns in the actual table as they are on the website. So if we then take another look at our output here, you can see it's starting to take shape. We're getting there. So now we have 4 new columns that have been created. We still keep our original column, but because we've split out that one into new columns, we have our challenge number, our challenge name, our level of difficulty, and then the main subject, which is fantastic. There's one last thing that we want to look at extracting here. So in this weekly challenges 2, this is where we have both the challenge URL and we have the challenge name. So we want to extract from this the URL, and then we will want to pull out the name as well separately. So to do that, we'll need to use another Regex tool, but this time we'll need a new output method. So if I bring in another tool and connect this up, now it's very important to choose the correct column to parse, because we don't want to parse from the first weekly challenges anymore. We want to parse from the weekly challenges 2, which is where we have that URL already extracted. And then I want to find my regular expression from down here. So in this case, I'm going to use this expression here, which will be used with the parse output method. I paste that in. Again, let's take another look at this expression so we know what it's doing. So in here, we're saying look for any ahref equals tag, and then return everything within the quotation marks. So these are just literal characters that it's looking for. The only ones that aren't are the ones in here. So this set within the brackets is our actual capture group. This is what will actually be returned into our output. So it won't actually bring back everything in this expression. We're specifying things outside the capture group so that it knows where to look. And then the capture group itself is what will be returned. So in here, let's change this output method over to parse. And we can see this has changed to tell me what's going to be output from my expression. This is important that if you don't put in any brackets into your expression when you're trying to parse, you'll get an error. So if I show you by just removing these brackets, Alteryx is smart enough to recognize that there's nothing to parse here. It doesn't have any brackets, so it can't bring anything back. So it gives me an error, which is good because that means it tells me I've done something wrong. So I know I need to go back in and put my brackets in. So down here in the output, it's quite handy because I can here rename my field. So if I click here, I can just change this to my URL field, which is what I'm pulling out. I can change the data type of this. It tells me the size as well. And it also tells me the expression that it is pulling out, because I could, if I wanted to, pass more than one thing from the same field in the same tool. I would just need more sets of brackets. And then it would tell me exactly which one it's bringing back down here. If I just show you what that means, any set of brackets that I put in, even if there's nothing inside it, it will still create a new row in my output column, because that's a new column that it's going to create in the output. So here we have our URL field being generated. So let's run that and then take a look at the output. So here we've still got our original fields, then right the way at the far right-hand side, we now have our field populated entirely by our URLs, which is great. So the next thing to do is to tidy up the rest of my table. I still have all these HTML tags in here, which I don't need, I don't want them. I just want these parts within the tags that have the actual text. So for instance here, where we have the beginner in our weekly challenges 3, I don't want these TD tags. I just want the beginner part within them. Likewise in the weekly challenges over here, where it says data parsing, I don't want the TD tags, I just want the data parsing. Same over here, I want to get rid of everything that's in here. I've already taken my URL out, so I don't care about keeping that. The only thing I want to keep is where I don't have those tags. So anything that's not within a tag, I want to keep that. So what I can do is use a regular expression to just remove anything that is within these HTML tags. So again, let's bring in another regex tool and connect this up. So now I can choose the column that I want to parse. If I just do this on weekly challenges 1 first to show you what it looks like. All we need for this expression is this. This is nice and simple. So all this is going to do is look for anything, absolutely anything within 2 tags. So the $? Question mark again is looking for anything up until the next closing tag that it finds. And what we want to do is keep on replace. So the replace function will find anything that matches my regular expression, and it will replace it with whatever replacement text I put down in the bottom. In this case, I don't want to replace it with anything because I just want to remove it. So that means I can leave my replacement text blank, and it will just remove everything that is within those tags. So let's look at this output. So here, weekly challenges 1 has been nicely cleaned up. We can see we've just got the list of all of our challenge numbers. So now at this point, I need to do the same process for weekly challenges 2, weekly challenges 3, etc. But I don't want to have to keep putting in lots of regex tools. That seems a bit laborious. Instead, we can speed this up and do it all in one tool. And to do that, we'll need to use the multi-field formula. So we can actually leverage regex within any formula tool. Anywhere that you write a formula in Alteryx, you can use regex, because there are expressions that leverage regex that can just be written into a formula. So here we can just do the same procedure across all of our fields in one tool. So if we bring in the multi-field formula and connect this up, now we need to set this up with our correct expression. So first things first, is select the data type to look at, which is going to be text. I want this to apply to everything except my URL. And I can also deselect the weekly challenges at the start. This is our original field. I'm not going to end up keeping this anyway, so there's no point touching it. I want to overwrite my current fields, so I'll deselect this. And now I need to specify the expression to apply to these fields. So if I show you here under functions and under string, all the way down here, we have these 3 regex functions. So these are the ways that we can actually use regex anywhere in a function, in a formula, across the entire tool. So any formula tools, filter tools, multi-row formula tools, you name it. So what we can do is use this regex replace to replace anything within a HTML tag across all of our fields. Again, I have a little cheat sheet here with my formula already created. So I'll talk you through the syntax of this as well. So if we drop this in here and then take a closer look. So the regex replace is the function. The first thing that we want to look at is the string that it's going to apply to, which is going to be the current field that it's looking at. Then here we have the expression. Note here, it's very important that you put your expression in quote marks. I put mine in single, but you can also use double, so double quotation marks. This just tells it that it's looking for a string, but because it's looking for a regex string, it will use it as a pattern. So here it's the same expression that we had in our regex tool. It's just the $* question mark within the tags. And then the last part over here where we have the other quote marks is the replacement text that it will put in. I don't want it to put anything in, so I've just put in the 2 quote marks with nothing in between. So it will just delete anything within the tags. So let's take a look at the output from this. And it's almost there. We have almost cleaned up our data completely. So we can now see that each of these have now got tags that have all been removed, and we've just got the weekly challenge name, the difficulty, and the main subject. So the final thing to do is to just do a bit of standard data cleanup. We want to rename these fields to be a bit more meaningful, and we want to get rid of some of the other fields that we're not interested in anymore. So we want to lose this first weekly challenges field over here. We don't need that. So what we can do first of all is drop in a dynamic rename to rename these fields over here, to just take the first row as our field name. So I'll just drop in a dynamic rename and connect this up to my multi-field formula. And then I'll change the setting here over to from the first row of data. And I don't want to rename my URL field or my original weekly challenge. I just want it to apply to the 4 that I created with my tokenize at the start. Lastly, I will use a select tool to just deselect this first weekly challenge field up here. So now we have our data table nice and clean and ready to do some simple analysis on it. So what we can do at this stage is take a look at the main subjects. You can tell from the ones at the top, most of these are just 1 word or 2 word. So in here, where we have our main subject, we have data preparation, which is 2 words, apps, which is 1 word. Let's take a look and see which don't match that pattern. So we can see which ones have maybe got more than 1 subject, which ones have got missing subjects, or which ones have got different types of subjects. So to do that, we can use another regex function called match. So if I head back over to parse and bring in another regex tool over here, we can connect this up. And now we can create a match based on our main subject. So if I select the column here to be my main subject, and the regular expression that I want to use is my last one in my cheat sheet here. So what this expression is doing is it's saying match whenever my whole string is a word. So the \w is any letters or numbers. So we want at least 1 or more set of letters. Then sometimes there's a space. So we've got that \s question mark, which is an optional space. And then we have a \w*, which means that we have 0 or more word characters. So instead of having to put \w+, but making the W optional, we can use the star instead. So the star makes that optional. So that means that we will get a match whenever we have 1 word or 1 word with a space and then another word. So all we need to do is change our output method over to match. Only thing we need to do here is change the name of the output field. So I'm just going to call this matched and lose that hash at the start. So if we run this, we will see that this now generates a new field, which is just matched, and it just gives me true or false as to whether my main subject field matches that expression. So most of these do. So what we can do, so here we can see one is false. This is false because there is a comma in there, which doesn't match our expression. So we can use a filter tool at this point to just explore the ones which are false by dropping this in and just selecting my matched column and say that I'll filter to when this is true. So now each of these out of the true anchor of the filter tool is going to be all of the ones that match, which is 176 records out of 180, which means we've got 4 which don't. Let's take a quick look at these. So we can see challenge 77 as using macros and spatial. 110 is using apps and macros. And then 136 has got analysis, parsing, and spatial. And interestingly, Cluedo has been misspelt on the page, which is quite funny. And 156 seems to be missing a main subject. So we don't actually know what subject that challenge is. So this was a very quick overview of building out a workflow using regular expressions to take some data out of HTML. I will take any questions now if you want to throw those into the chat. I'll give those a look in a moment. But if you are interested in learning more about Alteryx in general, please head on over to till.bi/talkdata. This is our meetup page where you can find out more about all the events that we're running. If you want to learn more about Regex and get more hands-on experience, we have an event coming up soon, Learn What the Data School Learns, where there will be a session based on Regex exclusively. So you can get some hands-on experience there if you can get down to London for the day. Keep an eye on the meetup, all the details will be put up there. We also will have all the material that I've shown today will be up on that meetup page as well. And once this webinar has been edited and uploaded to our YouTube channel, we'll also have a link to the content for you in there as well. So thank you very much everybody for tuning in, and I'll just have a look at the chat to see if we have any questions. Okay, so one question that's come in is, when do you use a Regex tool or a Regex in a filter? Which is a good question. So here I've used the tool and then I've used a Regex tool, then a filter. So this is just personal preference, I think. In this case, I used it to show off using the match in the Regex tool itself, but you could equally remove this tool and then in the filter tool in here, use the custom filter to use that Regex expression. So if I put in Regex match, I can do essentially the same function, just in a single Regex tool. I think it's potentially clearer for documentation purposes to use a Regex tool rather than a match within a filter. But ultimately, I think it's just personal preference. Thank you for that question. If there's any other questions, feel free to type them in to the chat now, and I'll come back to them. Otherwise, that is the webinar for today. So thank you everybody for tuning in, and I hope you have a great day.